In this video, I'm going to discuss the Ultra Prefetch engine that UltraRad provides. And I apologize for the audio quality. I don't have my microphone with me, but I just want to show you kind of a brief little explanation of how Ultra Prefetch is designed. So I'm just going to give you a brief overview. Ultra Prefetch basically consists of several components that together provide DICOM prefetching capability. And just to show you a simple workflow example, on this slide you can see we have Ultra Prefetch in the center, and to the left I've got a third-party RIS and PACS, and to the right might be our own RIS and PACS if we're a hospital. So the idea here in this basic scenario is that maybe we have a PACS system maybe across a WAN, or it could be a partner hospital, or something we're reading for, something along those lines, and we want to get it into our own PACS system. So the first step is usually the RIS would send us an ORM, which would have the order information about the study that's being ordered. We would evaluate that information, so we would parse out that ORM message. And by the way, we don't just use the messages in real time, we also store them persistently so they can be used later. So periodically we can check to see if there's any studies that are scheduled for tomorrow, for example. And that might be important if exams are scheduled well in advance, then we have to store them persistently so we can use them later on. But in any event, at some point we got an ORM that's going to trigger the workflow. So we get an ORM that tells us that there is a study that's about to be performed. We then do a CFind against the third-party PACS for all of that patient's records. We then also perform a CFind against the system that we want to send to. The reason we do that is we want to make sure that we filter from our list of studies from the third-party PACS or the origin of the data in the prefetch. We want to filter anything that already exists in the system that we're sending to. There's no reason for us to send it again if it already exists. So we're going to pull that stuff out. We call that our no-fly list. We are then going to parse that list, the remaining items in that list, for the routing or for the rules for the prefetch. So that could be matching based on relevance. It could be based on time. It could be keyword matching based on study description, body part, could be modality, things like that. So all of those basic rules that we're going to look at to determine which of those studies in the CFind response are appropriate for prefetching. Once we have that list for each one of those studies, we're going to send a CMove to the system, to the originating system. That system is then going to do a CStore, a DICOM CStore, to the PACS where we want that data sent to. Notice that CStore goes around the prefetch, so the prefetch doesn't actually handle the CStore. That's handled directly with the other PACS system, and we do that just because it's fewer moving parts if they send direct instead of going through the prefetch engine. However, the disadvantage is we don't know exactly when or if those images make it to the other PACS. So at some point, we'll typically go back and do a CFind to verify that the images arrived at the other PACS system. So that's how we verify that the prefetch that we kicked off actually finished. So normally when you send a CMove, the CMove association is closed by the other party once the CStore in response to that CMove has been completed, and we take one more step to verify that it's been completed by doing the CFind to verify the study is actually on the other PACS. If it's not there, we can either run the prefetch again for that study or the CMove again for that study. We could try it a number of times. We can send an email indicating a failure, something along those lines. Another example, if you can't do an HL7 interface, which is common, there's certainly many customers who can't do an HL7 interface. So in those scenarios, we'll get a CStore, and this is just one option. We could do a CStore, so we get an image or a study from a PACS system or from an archive, and rather than using HL7, that would be our trigger. So a DICOM header usually has the same information that we would find in an HL7 ORM message. Not as structured. It might not be as good, but it's enough for us to trigger an Ultra Prefetch job. And just like before, we can do our CFind using the information from the CStore, so we can use that to then go and find all the priors for that patient. We can do a CFind against the destination PACS to make sure we take anything out of the list that we already have on the other system. We can parse the results of the CFind from the origin systems for the relevant priors, all the things I talked about before. All that would work the same. And again, we have our CStore going to the destination archive, and we again would follow up with a CFind. One other option, if you can't do HL7 and you can't do or don't want to do CStore, another good option is DICOM modality worklist. So most DICOM modality worklist servers have the same information that we would be looking for in an HL7 message. So you can certainly do that as well. So we can periodically pull a DICOM modality worklist server, which presumably would be looking at a RIS for new orders, and we can then do the prefetch logic using that information. So you could certainly do it that way. So a couple different options as far as how to do this prefetching. So one of the other things I was asked to show you is the user interface. So let me just show you real quick. So this is the one example of the user interface. So this would be an admin type interface. Obviously, we got some things blacked out here because this was on a real system with patient data. But basically, you have a list of all the orders. And it doesn't have to be orders. That could be the information we gleaned off the DICOM header from a C-store. It could be information from a DICOM modality worklist query. But either way, we have all this information about what we need to trigger from. And then each one of those shows us, so for example, on that top window, if I click on one of the orders, in that middle window, I would see all of the priors for that particular study. So it would show me all the priors that we found for that study, unless the prefetch has not kicked off yet. So if we haven't kicked off the prefetch job yet, then you won't see the priors there, but you could manually kick it off. And at the bottom, you can see in the middle there is an action field. So the action tells you whether we did the move, whether we verified it, or some cases we don't move it because it's not relevant. So you would see that information there. And that would be all the studies we found. And you could highlight a study and tell it to try to move it again if you wanted, for some reason it didn't make it or something like that. You can also use this interface to modify the keyword matching rules, to modify your script so that the custom workflows. You can look at some of that stuff. So some basic functionality in the user interface as far as prefetching goes. An end user might use this interface. So this is our web user interface, and I'll maximize this to make it a little bit easier to see. So using this, you can check the status of the services that run the prefetch engine. So there are 3 core services that's used by the prefetch. Obviously, the HL7 one you wouldn't need if you're not triggering from HL7, but the other ones you typically would have. The script queues are basically like you saw on the previous screen, but it's web-based. So this would show you a list of studies that are pending or studies that have been prefetched, and you can, of course, break it down by different workflow scripts. So maybe this is prefetching for site A, this is prefetching for site B, and so forth. You can also check log files. So this will show you log files for each one of those workflows. What we call a workflow is basically different prefetch jobs or different types of prefetching. So for example, you might have a workflow for mammo prefetching, you might have a workflow for CT prefetching or something like that. So you can look at the logs for those individually. So for example, if I click on site B here, I can see in the log that there's an error connecting to client XYZ. So that would probably be the A title XYZ, and I would know that XYZ perhaps is down. Another common problem with prefetching is a user will tell you that I tried to I should have received this patient's record, but I don't see any of their priors. What happened? Where is it? So you can query for a specific patient ID or for a specific study or a specific order and look at the priors for that order. So I'll give you a simple example here. I'm going to choose site B, submit the query. So here we have a couple orders, so both of them for King testing. And if I click on this CT, for example, you can see there are no actions that happen for this one, but this would normally show you all of the studies that we found for prefetching. So this will show you exactly what was and what was not prefetched and when it was prefetched, so you could see all that stuff. So under action date, you would be able to see that it was moved to a certain archive, or it was sent to a certain archive, or we found it on. So client is where we found it, archive is where we had it sent, and the action date would be when that happened. The action is usually either move or store or something like that. So a couple different options to give you a little bit of visibility into what's happening in the workflow engine. And that's the basics for Ultra Prefetch.